Okay, let's talk about reaction types. So we have 5 different reaction types and they each have a general form. So I'll give you the general form and then I will give you an example of each. So composition, or I will call it a synthesis reaction, is where we would take A plus B and we would make a new compound C. And so we have 2 reactants and 1 product. So something like H2 plus O2 would yield water. Again, this is not balanced, but this is a synthesis reaction because 2 elements made 1 compound. Making glucose from carbon dioxide and water is another example of a synthesis reaction. We take 2 small things and make 1 much larger thing. So decomposition reaction is pretty much just the reverse of composition. We start with 1 element, or one compound, and we make 2 smaller things from it. And so this is what happens when you take glucose and you digest it and you get energy out of it. But we could just reverse our reaction here, and here we'd have water would decompose into hydrogen and oxygen, and that's another example. Again, not balanced. Combustion is kind of like what we did with the flaming pumpkins. We are going to burn something. So it's typically some kind of a hydrocarbon, H, N, and 2N plus 2. So any number of carbon and hydrogens plus oxygen. And we get out of that CO2 plus H2O. So when you cook on your stovetop at home, you're using methane and you're adding oxygen to it and a spark, and you get from that CO2 plus H2O. If we're doing grilling outside and we have a propane grill, we're using propane, which is C3H8, etc. What we did in the pumpkin lab, we used hand sanitizer, which is just an alcohol. It has an oxygen as well, but it's the same idea. Single replacement. So we have A, which is our cation, B, which is our anion, and we have some other material. It could be an anion or cation, and it would replace one of those two. So we would get AC plus B. So if C is an anion, it would replace B. If C is cation, it would replace A. So let's do 2 examples. Let's say we have KCl plus Br2 would give us KBr plus Cl2. In this case, Br2 is an anion, so it would replace Cl. But what if we had something like KCl plus silver, and we'll make those ions? Then we would get AgCl plus K ions. Okay, so if you have an anion as your second element, or as your element, it will replace the anion. If you have a cation as your element, it will replace the cation. And I guess you could probably guess what double replacement is going to be. We're going to have A plus B, AB plus CD. And we're going to remember this is our cation, this is our cation, so they're going to have to trade places. I'm going to leave them the same. So now B is going to replace D, and D is going to come over where B was. So this would be AD plus CB. So an example of that might be something like KCl plus AgNO3. Since K is with Cl, now I need K with NO3. So I'd have KNO3 plus, now I have to still have Ag, and now I'm going to have Cl in its place. And I did simple examples here because I didn't want to have to worry about stoichiometry and balancing equations, but you get the general idea. Now, sometimes single and double replacement reactions do not occur, and the way to know whether that will happen is you have to look at an activity series. So Here's the activity series for metals. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. It's silly, but it will get you all of the orders. And so these are the most reactive and these are the least reactive. And what that means is if something's lower on this list, it cannot replace something that's higher. So copper could not replace potassium, but potassium would replace copper or anything below it on the list. So if I had a solution, and let's do an example problem. Let's say I had something like, let's make sure you can see this okay. If I had AgNO3 plus, let's do zinc, will this single replacement reaction occur? And when I look at my two, here's potassium and here's zinc. Zinc is less reactive than potassium, or I'm sorry, I'm using zinc. So zinc and silver. Zinc is higher on the list than silver, so zinc could replace silver. And so this reaction would occur, and I would get ZnO3 plus Ag. Okay, how about if I had something like KNO3 plus calcium. Again, looking at my activity series, here's potassium, here's calcium. So potassium is more reactive, calcium is less reactive. So this is more and this one's lower, and so nothing could occur. Okay, hope that helps. Bye.